a little higher level of concepts today, which might take more time. So I'll try my best to cover everything within the set time. So let me start sharing my screen. Can you give me a thumbs up if you can see my screen right now?
Yeah.
With the pandas. Okay, thank you. All right, let's get started. Okay, that's okay. So today we are going to learn about data manipulation. This is our session 4. In the last 3 sessions, we learned about the introduction to pandas, first steps, and data preparation, data exploration, and we also partially learned about data manipulation in our last session, which is session 3. Today, we will continue to learn about data manipulation, some more concepts. And before we get started, we would like to thank JetBrains Academy who are supporting this course. We are following the curriculum of JetBrains Academy, their course, which is Gateway to Pandas. We will be covering the first section here that is mentioned here, which is, I'm sorry, this is my mistake. This should be pandas and not numpy. We will be covering majorly the theoretical concepts, but projects is something we encourage that you can try on your own because of time restrictions. So I would like to show you the interface of the JetBrains Academy course. Let me move on to the pie chart here. Okay, so this is basically what you can see on my screen is PyCharm Community Edition. Um, we have mentioned in the meetup details to install the plugin of JetBrains courses, but if you have not done yet, you can do it later. No worries. So this is PyCharm Community Edition, and then you can install the plugin. To do that, you can go to the settings like here, and then in the settings, you can go to the plugins and search for JetBrains Academy. So, and then that is how you can get the interface of JetBrains Academy. It's a very nice interface. As you can see here, on the left side, you will have the list to navigate through the course. What are the different chapters and exercises underneath it? In the middle, you have the editor for doing the exercises, coding exercises. And on the right side, for each chapter, you will have the explanations and examples. And then once you complete every task, for example, let me go to one of these chapters here, creating multi-index. So once you complete this exercise, here there will be a check button, and then it will check if there are any errors. It will display it and help you rectify and resolve the coding errors. So this is a very like one-stop shop kind of course where you can not only study but also practice together. And to install the course, you can, if you want to try any other course, there are a lot of courses provided by JetBrains Academy. For that, you could just go to File, and then in File, you will see Learn and Tech, and then go to Browse Courses. You will only see it once you install the JetBrains Academy plugin. So you can browse courses, and then in the marketplace, you can see there are so many courses available here, and you can just install it and get started. Okay, so that was a brief overview of the JetBrains Academy interface or course. Now, coming back to our main topics, let me go back to the slides for a moment here. Okay. So today, again, like last session, I'll be using very less of slides, and we'll be learning through the exercise more, like a walkthrough. However, I will be sharing the whole set of slides which have examples, small examples for each of the concepts that will be covered through this session. Okay. All right. Let me go back to the course here. So under data manipulation, we can see these are the topics on the left side. In the last session, we covered the first 3 topics, which is manipulation of rows and columns, multi-index, stacking, and unstacking. Today, we will continue with the rest of the concepts. So we will start with reshaping and pivoting of data. Then we'll see what is merging and combining data, and then transformation of data using different methods. All right. So first, we will try to understand how to reshape the data. So there are several methods in it. As you can see here in the slide, we have melt, which will convert the data from a wide format into a long format. So it basically melts the data into a longer format. And there is pivot, which does the opposite. It converts from a long format to a wide format. Okay. And then we have concatenation, which is basically like appending or sticking two pieces of data together in a rough way. So we can concatenate row wise, like here, or we can concatenate column wise, like you see on the right side. Okay. So if we concatenate row wise, we just use the default concat method. If we have to concatenate column wise, then we have to specify that by saying axis equals 1. Okay. All right. So we will see an example for each of these methods in our exercise. I'm going back to the pie chart now. Okay. Let me zoom in here. Okay, now I would like to see if everybody can see the screen, the coding screen. Can you please give me a thumbs up? Okay, thank you. All right. Okay, so in today's exercise, we will be using two sets of data. One is sales data, which is CSV format. And then along with that, we will have the employee data for the salesperson who are present in the sales data. We'll have an employee data, and both are in CSV format. So the initial set of code, as you can see, this is we are reading or loading both the CSV files into Pandas data frames. The first data frame is sales DF, and then another one is employees DF. And then first we will try to explore how the data is shaped, how many columns it has, how many rows it has. So I'll run these first few lines of code. I'm not going to explain those in detail because we have covered it in the previous sessions. Okay. So as you can see here at the bottom, the employee data looks something like these. These are the first 5 rows of the employee data set, and it has all these columns. And it has all these columns: employee ID, name, experience, region, department, and salary. It has total of 50 rows and 6 columns. Similarly, the sales data set has all these columns. These are the column names: transaction ID, date, who is the salesperson, and then we have the numerical values, which is quantity and sales, etc. Then this is how the data looks like. These are the first 5 rows of the sales data. And we can see here in the shape that the sales data has 1000 rows and 11 columns. So we now get a rough idea of what is the size of the data set and how both of the data sets roughly look like. Okay, so now we will see the examples of our melt method first. Okay, so melt method, as we saw, basically it converts the data from a wide format to the long format. Here in our example, what we will do is we have quantity and sales in 2 different columns. Now we will melt it so that both quantity and sales come under just one column, all the numerical values. Okay, so for that we will use this method here, salesdf.melt. And inside that, there are several variables which we have to mention. For right now, it will be confusing, but once I run the code and we relate it to the result, it will be, we can understand it better. Okay. So this is what we get after melting. See, this is the original data set. We have quantity and sales as different columns here. And now after melting, you can see that there is a column called as metric. which will say whether it's quantity or sales. And in the value column, we have all the numerical values, whether it's sales or quantity, all those values are now present in a single column. Okay. And we have limited to, we have removed all the additional columns and we just want to see transaction ID and salesperson. These are the only two columns that we have selected to be shown here. Okay. So how did we do that? So first what we did is we said sales df, which is our sales data frame, dot melt. And then in the ID variables here, we are saying that we in the rows, we only want to see transaction ID and salesperson. So those are the ID variables. And then our value variables. What are the values that we want to see in that one column? It is quantity and sales. Okay. And then what will we name this value column where we have all the numerical values? We will name it as the value column. And then what will we call the column or the column name where we have these two variables, value variables, wherein it will tell us whether it is quantity or sales. So we will call that column as metric. So now you can relate on how we got this result here after using the melt method. Okay. So any questions so far? Uh,
Yeah, Rajeshri, sorry.
yeah. Yes, Sandeep.
Uh, I have a question. When do we do this? Like, what is the need of doing it? Because I
Good
think
question.
by doing
Yeah,
that, we are creating one categorical column here, right? Like
exactly. Yes.
metric. And normally we don't, because after all, we have to feed these data for machine learning. So we don't, again, we have to convert it into numerical because machine won't understand the categorical feature. So just trying
Hmm.
to understand because this is very new for me, like why we are or when we do these kind of reshaping.
Yes, I was actually going to address that in the next step, and good thing that you asked because that is the next logical question. So there are, I can think of two cases where we can use this melt method. One is where we want to, let's say, we want to group the data and we want to do some aggregations after grouping it. So that is one. And then the second is when we want to plot or visualize the data. So I hope you're still seeing my screen. Okay. So just to explain the same thing, coincidentally, I just added this small piece of code where we can visualize this data, what we got after melting. So here, uh, I want to plot the quantity and sales into a bar chart. So, because of which I can use the melted format, wherein I'll say that on the x axis, I want the metric. So, we will have what are our metrics, quantity and sales, and y axis will have the value. And our data is melted data frame. So, when I plot this, you can see the result. Let me bring it to the screen over here. So this is one of the examples where we can use the melt. Does that
Right,
help?
right. But we can use with two different columns also, right? Like with previous data also, we can use like plotting the graph between sales and quantity.
Okay.
Uh,
You can use, but would it give you a similar output like um, yeah, like what we have here for visualization?
uh, yeah, I think we can plot uh, for visualization.
Okay. Probably, maybe you're right. But for me, I think if as a comparison, this is one application I can think of, visualization. And other than that, I'm not 100% sure. The only thing I can think of is when we want to uh, have everything in one column and then do some group by aggregations.
Okay, okay.
Yeah.
Right, right.
If anybody would like to add anything, if they have used it in their projects, they can share it. You're welcome to add to the response for Sandeep's question. Okay. Um, I can do one thing. So this, I have a limited knowledge of its application right now. Maybe I'll check furthermore, and if I come up with any further examples, I'll share it in the Slack channel. Is that
Sure,
okay?
sure.
Okay.
Yeah, yeah.
Thank you.
Thank you.
Okay. Um, okay, so let's move on to the next method, which is a quite opposite of the melt method, which is pivot. So in the melt, we converted the wide into long format. Pivot, it does the opposite, which is the long format, it converts it into a wide format. So here we will use the pivot method just to show as an example. We will take the melted data frame and we will turn it back into what it was. So we'll meaning the quantity and sales will be separated into two columns. So let's see. Okay, so here we are taking the melted df dot pivot. Our indexes are transaction ID and salesperson, and the columns will be metric. And then the values, we will take whatever is in the value column, right? So when we run that, what's this? You can see that we have the quantity and sales now separated. So it's in a wider format now. Okay. So let me do that. Just a second. Okay, because this every time the chart pops up, it keeps interrupting the run. Okay, so I have a note here. Okay, never mind. Um, all right. So after pivot, we also have pivot table, which is similar to the pivot table that you find in Excel, maybe. So pivot table is basically pivot with aggregation options. So we can do aggregation functions like sum, mean, or any other statistical values that we want to see. So here, as an example, we are taking again our sales data frame, pivot table. We'll try to see the sales per region and by category, that is category as columns. Okay. So basically, pivot table has these four main uh, terms or parameters. Index is the rows. So we will have the rows as the region, south, east, north, etc, and our columns will be categories. You can also have multiple indices or multiple columns mentioned as a list within square brackets. So our columns will be just one category, and then values will be the sales value, and then aggregation function is sum. You can also have mean or any other functions. So when we run this, you can see here we get the sum of sales per region and by region and the category. Okay, so we can add more levels to the column here. So I can maybe add after category, we can also add product. Okay, so now you can see we have two levels here. We have category and under that we have products. So that's a simple example of pivot table. Um, And pivot table, like I said, it's for aggregation, like sum and other functions. Then we have something called as a cross tab. Cross tab basically is gives us the frequency or the count of occurrence of any variable. So, for example, here we will try to see how many times what is the frequency of a product in every region. So there are always two variables included here. So our first variable is region, and then the second variable is product. So when we run that, let's try to see the output here. So this is the output. Remember, this is not the quantity. This is basically the frequency of how many times For example, the chair has appeared in the transaction in each region. Again, to better visualize it, we can use some visualizations. Here we can look at it in the form of heat map. So we will use the cross-tab data that we got, and we're plotting the heat map here. This is the data that we're using, cross-tab DF. And then these are some other parameters that are required for specifying how the chart should look like. And then let me show that. So this is a nice visualization where we can show the frequency or the correlation between this region and product, right? So you can see that 38 is the maximum value, and then this is, I think, gives us a better understanding of how they are correlated. So maybe in the central and east region, the desk has higher sales or higher sales, and then the lowest is the dark blue color here. So east, in the east the mouse, and in the south the tablet probably need um, more attention or more better marketing to improve the sales. So that is how you can visualize that. And we can also have aggregations in the cross tab, but usually pivot table is better for looking at aggregations because it is more flexible and it has more types of functions which we can use for aggregation. So here we're just using an aggregation of sum of the quantity. Okay. The remaining variables you can see are same. Parameters you can see are same. We are using the sales region and sales product. Additionally, we are mentioning the values of sales quantity and then the aggregation function of sum. And then we can also plot these sales quantity cross-tab data into a heat map. So which will give us a similar result. Earlier we saw the frequencies or the count. Now we are seeing the total. Sorry, this was the same one. This is our next chart that we get as a. So now we are seeing the quantity, but you can see basically the spread is pretty similar. Okay. So I'm going to comment these plots so that they don't interrupt our next time we run the code. Okay, so this was about reshaping the data, and now we will see how to combine data when we have more than one sets of data, how to combine them. Okay, so do I need to go to? Okay. All right, so let me go back to the pie chart. Okay, so now we will try to see how to concatenate data set. We will just see one small example of concatenating by the default axis, that is rows one below the other. Okay, so for that example, we will just create a small sample data of 5 rows. So this extra sales contains 5 additional rows. Let's say we have our sales data right now and we have received 5 rows of extra data that needs to be added. So in that case, we say pd.concat our existing sales DF data frame, and then the extra sales is the additional data frame that needs to be concatenated with the sales DF. So these are those 2 data frames. And then ignore index equals true. This basically says that ignore the indices of these 2 data frames, and after concatenation create a fresh set of indices starting from 0, 1, 2, 3, etc. Okay, so then let's try to run this code and print it out. Okay, so this is before concatenation data set. You can see the last row is 999. And then after concatenation, we have added 5 more rows. So the last row is 1004. Okay. That's just simple concatenation operation. Okay. I'd like to see if there are any questions before going to the next concept. Any questions? I'll try to answer the questions. If I'm not able to, I'll always get back later. I just want to share that I'm one of the volunteers. Whatever I'm presenting today is something that I have learned before and I'm learning and doing. So I don't claim to be an expert. I'm learning with everybody. So I'll just, if I'm able to, great, I'll answer it now. Otherwise, I will get back to you later. Okay. Uh, if no further questions, can we continue further to the next concept? Okay, thank you. All right. So next, what we'll be seeing is the methods to combine data sets like merge and join, which are very similar to SQL queries, SQL joins. Let me go to the slide for a couple of moments to see this. So if there are any beginners, we have something called as joins in SQL. And here, similarly, we have different types of merge and joins in Pandas as well. So we have inner join, outer join, left outer, and right outer join or merge. Okay, if we using the merge operation, you can say it's inner merge, outer merge, or otherwise it is inner join or outer join. Okay, so in inner join, basically when you have two data sets, we will only take the data, will the result will only be the data that is common in both of the data sets. In outer join, the result will be a combination. We will get the data that is common in both the data set, as well as any extra data that both the data sets have. So basically, it's all of the data. And then in the left outer, the result will be the data that is common between the two, and also the left data set, the first data set. And the right outer is just the complementary of that, the common data plus the data from the right data set or the second data set. And then we also have something called as cross join, which, as this image indicates, it will just give a combination of all the data in both the data sets. Okay. Okay, so now let's move on to see some examples of merge. Okay, so here what we are trying to do is we have the sales data frame and we have the employees data frame. So now we are trying to pull or merge the employee and sales data frames together. We want to extract some of the columns from employees data frame and bring it into the sales data frame. So sales data frame is our left data frame and the right one or the second one is our employees data frame. So to merge the two data frames, we will use sales df dot merge. And so whatever is our left data frame has to be mentioned first. So sales df dot merge, then the right data frame employees df on. We always merge two data sets when we using a common column between the two. So here the common column is employee ID. So we are using that as a reference to join it. So on employee ID column. And how is where we mention the type of the merge. Here we using outer. It can be inner or left or right. Okay. By default, if we don't mention the how, by default, it will result or it will consider as an inner join. Okay. So let's run this small piece of code and see what it gives us. So this is our merged data frame. Okay. And you can see that on the left side, we have all our sales data. On the right side, it has added the employee data related to each salesperson, like the region, department, salary. Okay. And you can see that there are some columns that are common between the employee data set and sales data set. So let me go, I'm sorry, not here. here where we saw initially what columns they have. So you can see that in the employee data, you have experience and region and employee ID. And also in sales data set, we have experience, region, and we also have employee ID. Okay. So whenever there is again common columns like having the same column names, experience and region, when we merge them, you can see that it has automatically added a suffix here to differentiate between the columns of left and right data frames. Okay. So that was merge. And then similarly, we have join. Okay. Merge is basically used when we want to merge or join two data sets based on a column. Okay. And then join is used when we are trying to join or merge data sets using an index. Okay. So again, let's look at the example here. All right. So here what we'll do is we will look at the same merge using join method. I mean, same thing what we did, combining sales DF and employee DF using join. Okay. For that, we will need index, right? So here employee ID was our column and we merged based on the column. Now to merge it, to join it based on index, we will set the employee ID column as index for both. So employees df dot set index employee ID, and then set index employee ID for sales df as well. And then we are joining them here. So sales df dot join, and then employees df, we are joining it with that. And then we don't need to mention an on here because we are joining them based on the index. And then how is the type of join? We are using the left here. And then let me run that. And again, you can see we have the sales data here. And then this is employee ID is our index. These are the sales data on the left side, and on the right side, it has extracted the employee data. Okay. Now there are two more parameters here, L suffix and R suffix, which is left suffix and right suffix. So this is basically to be able to differentiate the common columns, right? So we have region and experience as the common columns. So this here, what it says is wherever we have common column names like experience or region, give the suffix, add the suffix of underscore sales for the left data set. And for the right data set columns, add the suffix of underscore EMP. So here, that is why we see the region having the suffix of underscore EMP because it's coming from the employee data set. Okay. Okay. So that is how we join. So remember, join is used when we are joining based on index. When we are trying to join data sets based on columns, we use merge. So here we're just trying to reset the index so that employee ID is not used as or not set as an index anymore. So then we'll try to see another method called as combine. And before that, any questions?
Yeah, Rajeshri.
Yes,
Mm,
Sandeep.
When we say based on index, like based on employee, I understood because that's a common column, so it will, map out. Uh, so that's how it is. But how exactly it is based on index? Like, for example, if we will go with SQL, so table A is having like four index 0, 1, 2, 3, 4, and table B is having 0, 1, 2, 3, 4. So if we are
Mm-hmm.
uh, like joining based on index, how it will be like 0 will be mapped with 0, 1 will be mapped with 1. Is it like that it is joining, or how is it like
Yes,
joining?
that's how it is joining. So here we have set the employee ID as the index, so it is joining based on the employee ID. And if we have not set it, let's try it. I did not try that. Um, let's try that. You're saying if we have just the default in indices, right?
Yeah, yeah, I mean, how exactly here the joining is happening? Like employee ID, we say that set index, because each
Ah,
table will have an index. Yeah.
yes. So each row will have an index. Here we are setting the index as employee ID. So I'll just comment this so that now we will have the default IDs, and then let's see what happens. Okay. Yeah. So now you can see that it is being repeated because it's just combining based on the index values, that is 0 to 0, 1 to 1, right?
Okay. Okay.
So that's why yeah, I think it is just combining based on the default index values.
Okay. Okay.
Okay,
Right. Right, Rashi. Got it.
okay.
Thank you.
All right, so let me put it back. Yeah, okay. Um, the next method is combine. So there is combine and there is combine first. Okay, so just to do a small recap, with merge and join, what we did is we added additional columns from a different data frame, and in concat we added additional rows from a different data frame to our existing sales data frame. Combine is used can be used when we want to combine, like say we have a sales data set, our sales data set, and then there is an updated data set. Okay, and we want to compare it element wise, every element by element, and then we want to update based on a certain condition. For example, here we'll take an example where we have a new sales data set, and we have a old sales data set, and we want to update our old or existing sales data set. We want to compare both of them, and we want to pick the maximum sales value. So if our new sales value is higher than our existing sales value, we want to replace it with a higher value. Okay, so element by element, we will compare and we will choose. In such cases, we can use a combine. Okay, so here in our example, let me uncommented. Okay, so here what we are doing is we'll take a copy of our sales DF. Okay, and then we are just changing the sales value for some 5 rows, and then we will use this new this adjusted DF to combine it with our sales DF. Okay, so let me run this. Okay, so this is our original sales data, okay, from first 5 rows, and now we are creating an adjusted sales data where we are adding new sales value for the first 5 rows, only first 5 rows. Okay, now what we will do is we will compare our existing original sales data, adjusted sales data, then we will say that we want to update the values and pick the maximum value. Okay, so here we are defining a small function which will compare x and y and will return the maximum of the x and y. Okay, and now we'll use this function in our combine method. Let's see that. Okay, so here we're saying sales df dot combine adjustments DF. So we are comparing sales DF and adjustment DF, and then we will apply max values function to each of the element. Okay, so now when we run this, all right, so you can see that after combining, the first 5 rows are updated with the new values, which have higher sales value compared to the earlier. So it has been updated, and all the other values are same, so they will not be updated. Um, is it clear? Any questions for combine? If it's clear, please show me a thumbs up so I can continue. Okay, we're running out of time, but I'll try to cover. Okay. So we have combine, we covered combine, and combine first is basically something we can use to fill in missing values. Okay. So let's see an example. Again, here we are taking a copy of our sales DF, and we are in the copy, we will replace some of the rows 5 to 10 with none. Okay. And then we will use combine first to replace these none or null values with our numerical values. Okay. So here what we're doing is we created a sales GF copy, replaced rows 5 to 10 with none. Okay, so this is something we'll work on. So now here we are using combine first, where what we're doing is we are saying that for the sales column in sales GF copy, use combine first and then apply this function, which is replace 100. Okay, wherever we have null values or none missing values basically. Okay, so note we're not modifying the sales GF, we're just modifying the copied version. Okay, so when we check that, you can see that row wherever we had null values here from 5 to 10, now it has replaced with 100. Okay, so combine first is basically used to replace the missing values. Now coming to group by. Okay, so far we covered the combining methods. Now we will see some aggregations using group by, how to do aggregations. Okay, so whenever we have data which has categories like different types of products or regions or departments, we want to see what is the total for each department or each category. In those cases, we can use group by along with some type of aggregation. Okay, so here is an example. Here we're trying to see the sum of sales for each salesperson. So we are doing sales GF dot group by. We are mentioning the column here, and for each column we want to see the sum of sales. So sales dot sum, and if I run this, you can see for each salesperson, it will give the total sales values. So you can try using different functions here instead of sum, and you may be using multiple columns. Okay, so then along with group by, we can use something called as apply and transform. So apply will basically give you, will let you, uh, just like we used sum here, if you want to use any customized function and apply it and get the result for each category, that is when we use apply. Okay, so let's try to look at the code quickly. Sales TF, so we are using group by, same thing, category, and we're using the column sales, the sales values here, and we are trying to get the sum, but just to show that we can use a customized function, we're using apply, and here it's just taking the sum, right? X, for each X value, it's calculating the sum. So this is basically just gives us the sum of sales per category. Okay, so we'll get one value per category. But there is another function called as transform, which will give a similar result, but it will give the result for each row, basically like adding one additional column. Okay, so let's see an example for that quickly. Okay, we have 5 more minutes. Okay, so apply we covered. Now here we're using transform. What we are doing here is first we are trying to normalize the sales value. Okay, normalizing basically. Let me restart. Okay, so first we are trying to do a group by as usual. Group by for each region, we are trying to see the sales values, and we are trying to do aggregation using a customized function. Okay, this is our customized function, which using this function, we are trying to normalize sales value per region. Normalize is basically trying to convert the sales value, which might be in dollars or pounds, from on a scale of 0 to 1. So for each region, whatever minimum value is there, will 0 will represent that, and the highest value will be represented by 1, and all the other values will fall between 0 and 1 for each region. So that is the normalization that this function is doing here. Now, so we are doing group by, and then we are using transform to apply this function for the sales column. And now let us try to run this and see how it looks like. Okay, so these are the first 10 rows that we get as a result. Okay, so you can see that we have the normalized values of sales for each region. Okay, now what is the difference between apply and transform? Apply basically gives you one result for each category. It might be sum or anything, it will just be one value for each category. Whereas transform will give you one value for each row. It will not change the structure or shape of the data frame. It will just add, it's like adding an additional column in the data frame. Okay. So now just to show the normalization or visualize it, we will plot maybe a chart here. Just to understand what we did. Do we have it? Yeah. So this is the chart we get by plotting it here. So here we have all the regions, and for each region, you can see that the sales is being represented from 0 to 1. Okay, so now how would I interpret it is, um, you can see here there are or sales value ranging from 1000 to 4000, which is the color code that has been used. Okay, so by looking at that, we can say that wherever, for example, on the first central region, we have a good distribution of both lower and higher sales values. Although the higher sales values is there is still slightly gap, but it's still more compared to the other region. And in the west, we have a good distribution of both higher and lower sales values as well. But in the north region, we see in the north and east region, we see a gap of in the lower sales region. Okay, so we don't see a uniform distribution. So maybe the products that have higher values are being sold more, where we have this green color or the longer lines in more numbers. Okay, um, you can come up with your own interpretations here, but this is what I see by just taking a quick look at it. And then I just try to do one more plot for the same data. Let me open that up. It takes some time to run, sorry. This is the first one. Yeah, so this is the box plot again. So wherever we see the length of this rectangles will represent the range of the values, and wherever we have this median, this line at the center here. So if it's a lower, how do I say, um, the lower, I'm sorry, the value of the sales is on the lower range, it's more on the lower side, and the sales of higher value products is less. And the dots, if they're crossing these, if they're seen outside, for example, like here in the east, there is one dot that is going outside of this line. So these are called as outliers, which is extremely away from the usual sales values. Okay. Um, yeah, so that is how you can, this is just not related to the concept we're trying to understand, apply and transform, but just to understand what we did, I thought adding the charts would be better. Okay, so concepts have been covered. Now I'm open to questions. Any questions regarding the session, regarding the concepts, or anything else? Because this is our last session. Please go ahead. I'll stop sharing my screen. Yes, Sandeep.
Yeah, Rashri. So you have mentioned we have used a transform and we have used a formula x minus x mean by x max minus x mean. I mean, uh, basically we are doing normalization there. We can use min max scalar also, right? Like both are the same things, right? Uh,
Mm-hmm.
so what is the need? Like uh like uh, why exactly we are using this transform? Like transform function.
A transform function basically, so that the normalization part was just taken as an example, but the whole point was to show that any function you take, any customized function you take, will be applied row wise, or it will show up row wise when we use transform.
Okay. And any customized function we can do it with apply also. Yeah.
Yes, we can do it with apply also. But see, for example, if you have, let's say you're trying to calculate, let's say our customized function is as simple as what is the sum of sales for every region. Okay. When we use apply for that, then let's say you have only four regions, north, east, west, south. So it will give you only four values, four rows when you use apply.
Okay.
When you use transform, it will give you the same value will be repeated, but wherever you have, like if you have 10 rows with north, east, south, west repeatedly, it will show the sum for each region in every row if you use
Okay.
transform. Is
Okay. Okay.
okay,
Got
yeah,
it. So it's like for every record we will get this the
exactly.
calculated value.
Yes, you may have repeated values, but it will show up so that the data frame's structure is not modified.
Okay. Okay. Got it. Got it. Yeah. Thank you.
Thank you. Any other questions?
Not regarding session, but because this is the last session where we will find all the recordings of session.
We will be posting the recording in our YouTube channel. There is a Women Coding Community YouTube channel,
Mhm.
and all of the previous recordings are available over there. And even in the meetup, just under wherever you have this event, in the comments, these the links to the YouTube videos have been posted as well. Uh, Also, you can join the Slack channel of Women Coding Community Python Coding Club, and even there the links will be posted.
Yes, I have joined, and I mean there are three channels. They're general, random, and empower women to excel in technology and career. Uh,
Okay.
so uh,
You
where
should
exactly?
choose, yeah, you should choose all available channels, and our particular, I will send the link. This is Project Coding Club channel. When you will do a search by Slack, by our Slack, you can find it there, or use this link.
Okay, okay, okay.
Yes,
Thank
or you can search this is the channel name. You can use the link, or you can just search in the for this channel in the
Mhm.
Slack,
Okay, okay,
and then you can just join it.
Yeah, this is the open channel, so you don't need any special access there. It's just available for everyone.
okay.
Yeah.
Cool.
And there is also machine learning club if you want to learn the data science part as well. Uh, yeah. Also, there is a SQL challenge that is being currently running by the women coding community on Hacker Rank. So you can sign up for that as well if any of you are interested.
How to join these channels? Because by default it shows me, as I said, like on the three channel it shows, and yeah, I have added to this programming coding club Python, and
Mhm.
yeah, I'm interested for machine learning, and those kind of projects. So how I
So
can?
in the search bar, you
Yes.
can okay, just a second. I have to do it so I remember how to. Um, Yeah, in I would go to the search bar and try to find like type hash. And then browse for channels. Somewhere it gives browse channels option. 1 second, let me check. Mhm. Where did I see that? Yeah, so add channels.
This is on
Yeah.
the uh-huh.
So on the left side in the Slack, you see a list of whatever groups you have joined, right? All the channels you have joined. And under that, at the bottom, you have an option called as add channels. All right.
Yes.
If you click on add channels, you can see a browse channel option. Let me share my screen.
Okay. Okay. I can
You
see
see
with
that?
yeah, I can see
Yeah.
like I have joined from like I'm accessing from mobile, so I can see with like it's like dictionary wise A B C D and all the channel there.
Okay. So hold on. Let me share my screen. So can you see my Slack on my screen right now?
Yes.
Mhm.
Okay, so here are all the channels, and at the bottom we have add channels. Click on that, click for browse channels, and then you can see anything like machine learning. So it will give you all the channels related to that.
Right. Right.
Okay,
Right.
so and then you have also book club. You can see book club here, so something like that.
Awesome. Awesome.
Okay.
Okay. Yeah.
This is the website, and there is a link to join our Slack here as well. Anybody interested to join? Okay.
Cool.
Mhm.
Cool.
So, anything else? Anybody want to ask or share? Um, Nona, would you
Mhm.
like to add about any certification? Any points about certification?
Mhm. Right now, I'm stopping the recording.